All right, guys, so what we're doing today is we're starting chapter 4 of the green textbooks because this chapter 4 is not out of the Big Idea Math book. And what this chapter is going to be completely over is matrices. Now, we have covered matrices before. We covered them in August briefly, and we're going to cover them again this week in a little more in depth in a few different areas and more of the things that we can do with matrices. Now, the first thing we're looking at is, well, a matrix. It is an arrangement of data in a horizontal and vertical form. Horizontally consists of our rows, vertically consists of our columns. And we went over this before, and we can name a matrix by its dimensions, which are the rows and columns. So if we look at matrix A here, well, it has 3 rows and 4 columns, so its dimensions would be what? 3 by 4, because that would be the dimensions of the matrix. Now, each number inside of the matrix is going to be called an element. So each number inside the matrix is an element. Now, this is in August when we covered this the first time. So if we look at this here, now there is one point at the number -1, the element -1. Now, we will name this as little a to 1. Capital A will be used to define the matrix itself. The lowercase version of the letter will be used to define the element. So here, 2, 1. Well, what do we think the 2 and 1 are? Well, first row, second row, first column. Second row, first column. 8 down here would be third row, second column. And we can name any element in the matrix by this way here. Just how do we get to it? Rows by columns. Now let's look at some naming dimensions and finding the element. Looking at this here, define the matrix A. Because it has 2 rows and 3 columns. And the main way that I keep it straight is we go down and then over. So if we go down, how many numbers are down? Going across, there are 3. We always start in the top left corner. Now let's element to 1. So what would it be? Which is positive 9. So we can always start in that top left corner again. So second row, so we're going to go down to the second one. And then over 1, which just puts us at positive 9. Now A22 would have been negative 9. Any questions on this here? We good with this here? All right. State the dimensions of matrix B. 3 by 2, 3 rows, 2 columns. So it is a 3 by 2. Now we also want to find the value of B, 3, 2. Which would be, because third row, second column would be negative 1. Questions on this here? Now, I think y'all feel pretty good with those there. Now, there are special types of matrices that we have. The first one is a row matrix. And, well, why do we call it a row matrix? Because it only has 1 row, right? We also have a column matrix, which has 1 column. We also have something called a square matrix, where the number of rows and the number of columns are the exact same. Well, it looks like a square. And the last one is a zero matrix. Well, it's a zero matrix if every element in the matrix is 0. We will have the zero matrix. Questions on this so far? Addition and subtraction. Now, we covered this once before. We did cover it in August when we covered matrices in chapter 1. And we will look at it again here today. The main way that we can add two matrices together or subtract them is if their dimensions are the exact same. So here we have a 2 by 2, and here we have a 2 by 2, and C is a 2 by 1. Now for this first one here, it asked us to add matrix A and matrix B. Can we add the two together? Yes, because they're both 2 by 2. Well, matrix C is 16, -9 and 8. And we're adding to it -4, -3, and -7. Now, because there's an addition sign between those two matrices, we're going to add the corresponding elements. So here we're going to take 16 and add 2 plus. Then we'll have 2 plus -1. -9 plus -3, and 8 plus -7, because we're adding the corresponding numbers. Well, -16, or sorry, 6 plus -4 would be 12. 2 plus -1 is -9 plus 3 would be, and 8 plus -7. And that's it. That's all we have to do for this here. Any questions on this here? Now, was there another way that we did this in August? We could do it in the calculator. Before we jump to do it in the calculator here, let's make sure we can actually do it. Because B is a 2 by 2, yes? C is a... Can we take B minus C? No. So this here is not possible. If you plug this into the calculator, because you can still plug it in and hit enter, it's going to give you this, error INVDIM, invalid dimensions. It's going to say the dimensions aren't valid, it can't work. Because we'll cover multiplication as well, but with addition, subtraction, or multiplication or division, if it's not possible, it'll tell us it's invalid dimensions. It just doesn't work. It's here, it won't work. Well, let's look at the next one here. A plus B plus A. A plus B plus A. This works because A and B are both 2 by 2. So this will work. Weird. Oh, need more? All right, guys. So let's look at how we can plug this in. Now, what we want to do first is we want to define matrix A. You want to grab a calculator? Okay. So we're on the top of A plus B plus A. So we want to define matrix A and B first. So the way we can do that is by going second matrix. And then we'll want to go over to edit to be able to edit or put the matrix in. Now we can go on and just hit enter because we want to edit matrix A first. Now the matrix that we want to put in is a 2 by 2. So we'll do 2 enter, or we can do enter enter if it's already a 2 by 2. And then we can put the elements in. Well, the first element is 16. Then 2, -9, 8. Now after we put the first one in, we could go second quit, second matrix edit. But it actually works out while we're still editing matrices, we could actually go second matrix and then go over to edit. Now we don't want the first one, we're going to want the second one because we want to enter a second matrix in. Because we define A as actually matrix A, and we're going to define matrix B as matrix B. It worked out that we could do that. And it's going to be a 2 by 2. And we're going to have -4, -1, -3, and -7. And when we put the numbers into the matrices, we're going to have to use the negative sign, not the sign. It will throw it out. Any questions so far on how we inputted matrix A or matrix B? Now that we've gotten both put in, we can go second mode, second quit. We're back to the home screen. Now we just need to recall them. Now to recall the matrix, we're going to go second matrix, and this first list here will recall them and use them with the subtraction multiplication. And if we hit enter, it'll pull up matrix A. Because that's what we had first, was A plus matrix B. So we can say plus second matrix, then we would call up B, and then what did we have next? Plus second matrix A. And that's what we're wanting to do. Yeah, A plus B plus A. Once we get that put in, go on and hit enter. And that's the answer. Yep. So down here is the key press history. But that would be the matrix if we added these together. Any questions on this here? Any other questions with addition or subtraction of matrices? So we good with doing addition and subtraction? All right. Let's look at scalar multiplication. Now this is, we also did scalar multiplication in August. We've covered this one before. Whenever we multiply by a scalar, we're multiplying every element inside that matrix by that scalar, by that number. So here, 5r, well, I'm multiplying 5 by the matrix, -12, 8, 6, 14, 19, or 4, 19. So we're multiplying each element in the matrix by 5. So we have 5 times -12, 5 times 8, 5 times 6. Then we'd have 5 times -16, 5 times 4, 5 times 19. We're just multiplying each one of those numbers by 5. And then we just need to multiply them together. 5 times -12 would be -60. 5 times 8 is 40. 5 times 6 is 30. 5 times -16 is -80. 5 times 4 is 20. And 5 times 19 is 95. And that there would be the answer for multiplying by the scalar of 5. Any questions on this here? Now we could do this in the calculator and have the calculator do it for us. Are there any questions on this example before we look at the next one? So for the next one, if t is back there, find t. So we can do that one here in the calculator. Well, the first thing we need to do is actually input the matrix into the calculator. So to do that, we're going to go second, matrix, edit, and we'll just put this in matrix A. Now, matrix A is a 2 by 4. And when we do the dimensions, it does make it look like the matrix we want. Now, here we want 8, 0, 3, negative 2, negative 1, negative 4, negative 2, and 9. Because we can put the whole matrix in. If we're not having to input any other matrix in, we can go second, quit, and get back to the home screen. Any questions on putting it in? Are we good there? Everybody got it typed in? So we can go second, quit. Now we're wanting to find negative 4 times t, yes? Well, we'll start out with what? Negative 4. Now we need matrix t. Well, we define it as what? Matrix A. So we can go second, matrix, and enter. We'll pull up matrix A, the one we put it in, yes? Then we just need to do what? Okay. Now with scalar multiplication, doing it in the calculator like we just did here, having the calculator do it for us, just doing it by hand, really the amount of time it takes to do either, really, you're not saving much time doing it one way or the other. Because for us to be able to just multiply each element by negative 4, or typing it all in and letting the graphing calculator do it, is going to come out to be about the same. Just depending on how fast you can do, say, the multiples of negative 4. Definitions on scalar multiplication. Now there's some more things that we could do with commutative property of addition, associative property, scalars left and right, is well, we can combine the two, and we did do this in August, where we can do the scalar multiplication and addition and subtraction. Now if we do this by hand, negative 4b, well, 4 times the matrix B, I'm going to show you how to do this by hand, and then we'll look at it in the calculator. Because if we do this by hand, the first thing we need to do is actually multiply by the scalar. For this first matrix, I'm going to multiply everything by negative 4. Well, negative 4 times negative 4 would be positive 16. Negative 4 times negative 8 will make a positive, and it would be 32. Negative 4 times 2 is negative 8. Negative 4 times negative 3 is 12. We just multiplied through by that scalar. Now, on the next one, because we do have minus 3 or negative 3, we can multiply through by negative 3. We can multiply through by 3. If we multiply through by positive 3, we're going to end up subtracting. But if I multiply through by negative 3, we're going to add, because I took that negative inside. If we multiply through by negative 3, the negative goes inside, and we'll just add. If we multiply through by 3, the negative will stay outside. I'm just going to multiply through by the negative 3. so we don't have to deal with subtraction.
Well, negative 3 times negative 9 is
27.
negative 3 times negative 8 is
Positive 24.
Make sure, because nope. Because that should be negative 9, 12, 2. I have matrix B plugged in.
Did y'all see that?
Because these should be negative 12 and 6. Because now it should be negative 3 times 12, which should be negative 36. Negative 3 times positive 2 should be, and negative 3 times negative 6 should be positive 18. And lastly,
all we need to do is add our terms together.
So 16 plus 27 is going to be
43.
32 plus negative 36 is
Negative 4, because 32
minus 36 is going to be negative 4.
Negative 8 plus negative
6 is negative 14.
And 12 plus 18
is 30.
Questions on the Now we could have done this exact same problem in the calculator. We could have plugged this onto the calculator and got the same thing. So if we look at this here, well, we can go second
matrix and go over to edit and edit matrix A.
And just type it in. Now the matrix is a
2 by 2. And A is negative 9, 12, 2, negative 6.
And really, when you're typing in, it's easier to hit enter than to use the arrow keys.
But we got the first one typed in. We can go second quit, well, second matrix, edit, matrix B.
Or we could just go on second matrix, edit B.
We don't have to do second quit if we don't want to. Matrix B is a
2 by 2.
It is negative 4, negative 8, 2, negative 3.
And once we get it all typed in, we can go second quit. Now the one we want is negative 4b minus 3a.
So I can say negative 4. Then we would go second matrix down to B minus 3 second matrix A.
And if we hit enter, we get this here. Is that the same thing we got when we did it by hand? And it'll do it for us. Any questions on here? So we got with addition, subtraction, and scalar multiplication added in. All right. Multiplication, the last thing we are looking at today. You can multiply two matrices if and only a number of columns A is equal to the number of rows in B. We can multiply two matrices as long as the columns of the first is equal to the rows of the second. And if it is able to multiply it, the rows of the first by the columns of the second will be the new dimensions, what our new matrix will be.
Now let's just do an example of this here. Let's say A is 1 by
9,000. That's a pretty big matrix, yes?
If it would be able to multiply by B, it means the columns
of the first would have to match the rows of the second has to match the columns of the first.
So both of these here have to be
9,000, which is a pretty good sized matrix, yes?
and then lay by 1. Since the columns of the first
Match the rows of the second, it tells me that these two matrices will be able to be multiplied together. Now the new dimensions will be the rows of the first by columns of the second. So what's our new
dimensions going to be?
Well, 1 by 1 is a single element. So the multiplication of 1 by 9,000 and 9,000 by 1 is actually a 1 by 1.
So really when you multiply this,
It actually would just be whatever the number is, but it would look like that. So
the first one would be a
column matrix. It would be a column matrix with 9,000 different items in it. Matrix B would be a row matrix. So a single row with 9,000 entries. And when we multiply the two together,
we get a 1 by 1.
I had it flipped, but
yeah, this here would be 1, and this way B
would be this way here. And when you multiply them, we get a 1 by 1.
Yes.
If you'll go in that closet, you can turn on the light if you want. It's going to be down on the left. There's just a box of them. Light's shoulder height right there. So keep going down, yep.
Let's look at this here. So we want to do A times B.
Columns of the first and rows of the second, do they match? Because they're both 4, yes? So the second number and the first one are multiplying the first number
and the second one, so they're both 4
and 4. So yes, we can multiply them.
And what are the new dimensions? It'd be 3 by 2.
And whenever you do these, you can rewrite them and see where it's columns, what's rows, so we can see what's matching.
So let's look at this one here.
So what is the number of the first?
What's the number of rows of the second?
Are they the same?
Can we multiply these? No, this here is not possible. Could we have flipped it and done B times A for this one here? Well, B's column is
4. What's the
rows for A.
Could we have done B times A? No.
Let's look at 1A. So if we do A times B, what's the number of columns in A? What's the number of rows in B?
So can we multiply A times B?
And what would the new dimensions be? 4 by 2.
With this one here,
Could we have done B times A? Because B's columns is 2 and A's rows are.
So we can't do B times A. But we can do A times B. That's perfectly fine. Any questions on this here?
Well, we have the last one. Can we do B? No, because it would be 2 and 3. How about B times A? Because it would still be
3, yes. There's no way that they do match up. Any questions on this here? Because we're going to actually start multiplying. It's not that. with multiplication of two matrices, really this is the over and down, really what we're going to do, or an over and down method. Whenever we multiply two matrices, we're going to multiply over and down. And this gives us the first element. And we do it again and down, gives us the second. Again, we're going to go over and down, over and down. And we repeat this process for however many elements, doing the same thing to multiply. Now this will make more sense when we look at it. So we're going to multiply x and y. Give you all a second to get it written down first. So what we're going to do is we're going to go over with the first row and down with the first column of the second. So we're going to use the first row of the first matrix and the first column of the second. And we're going to multiply. So we're going to do, our first number is 6, and we're going to multiply it by 5. Plus, our next number in the first row is, and it's going to be multiplied by 3. First number, second number, second number. We're going over and down. Over and down. And this is partially why the number of columns in the first has to match the rows in the second. Because the first one, how many do we have? 2, yes? How many rows do we have in the second? 2. So these 6 and 3 matches up with those there. So if I had 3 in the rows and 2 in the columns, well, I don't have it matching. There's going to be a number that's offset. Any questions on the first part here? Does that make sense? Repeat. Because now we're going to go first row, second column. So we'll have 6 times -4 plus -3 times 3. Questions on this here? We ready for next? Because now we've done everything with the first row, because the 6, -3, we went to the first column, second column, we don't have a third, so we're done with it. We drop down to the second row and repeat. So what we'll do next here is we'll have to get it 10 times -5 plus times 3. And last but not least, we'll do this again with, well, -4 and 3. It becomes -4 plus -2 times 3. And I think some of y'all were able to figure out that pattern already, yes? Questions on this here? Yeah, so no matter how big the matrix is, if we can multiply it, we would do the same thing for each of every single element. And last but not least, all we need to do is simplify these numbers down. So we can do 6 times -5, which would be -30. -3 times 3 is -9. 6 times -4 would be -24. -3 times 3 is -9. -10 times -5 would be 50. -2 times 3 is -6. And lastly, -10 times -4 is 40. Bless you. And -2 times would be -6.
Negative 30 minus 9 would be negative 39. Negative 24 minus 9 is
negative 33.
And minus 6 is 44, and 40 minus 6 is 54. So our matrix x times y is equal to the matrix negative 39, negative 33, 44, and 34. Questions on how we did this here? We're good with this here? So, I mean, it works in all different matrices. Well, why don't we look at it in the calculator, just so we can see how this works with the calculator. So if we're doing this in the calculator, well, the first thing we need to do is edit the matrices, yes? Well, do we have x and y? Well, no. The farthest this will go is j. But we can still use a and b, yes? Now, if it's better to keep track of if we're doing multiple things, you can write a and b above the matrices to remind yourself which one we defined it as. So we can go on and just define matrix x as a. So we can hit enter. It is a 2 by 2. So we have 6, negative 3, negative 10, negative 2. And once we get that typed in, we can go second matrix, edit B, 2 by 2. This here would be negative 5, negative 4, 3, 3. Well, we have both of them typed in, yes? So we can do what? Second quit, second, almost, second matrix. Now we wanted x first, so A. Second matrix B. Luckily, typing next to each other, the calculator will understand multiplication, not addition, subtraction, or division. So we can go on and hit enter, and we get negative 39, negative 33, 44, and 34. Is that what we got before? I'm going to just try this. Let's go second matrix B, second matrix A. So B times A, yes? What do we expect to happen? It will change. Multiplication with matrices will not be the same. A times B will not give us the same thing as B times A. Now, I'm going to erase this here. I won't work it all the way out because we do know what the answer is already. And I don't like the fact that I'm not going to work this all the way out. But the point that I want to make, be able to make it before we get all the way through it. Because this here is y times x, the reverse, yes? Now, if we go over and down, like I did, we would have negative 5 times negative 4 times, this is not in the note sheet. Looking at this here and the one that we did with x times y, has the function already changed? Yeah, because the numbers are completely different, aren't they? This is why multiplication is not commutative. A times B is not going to be the same as B times A for matrix multiplication. But that's it. Are there any other questions?